I hope you're doing fine. The topic for today's video session is regression and prediction. What we'll be covering, just have a quick glance at it. We'll be talking today about how to make predictions based on the information we get from correlation. What is regression? What is linear prediction rule? What is regression line and line of best fit? The concept of standardized regression coefficient and multiple correlation. So let's begin. Now, prediction, the word you must have heard, to predict, to estimate, to forecast. So if two variables are correlated or related, associated, can we make predictions about one from another? Take an example that suppose I want to know how well a person applying for a job is likely to perform if hired on the basis of a test. So psychometric test. So on the basis of the scores which I get from the psychometric test, I want to predict how well, how likely the person is going to perform on the job. Similarly, to take another example, although there are many I have given, but the more common one is, does your SAT scores or any entrance exam, SCAT, math scores, predict your grades in college? So can I say on the basis of your SAT scores that you will be performing in this manner in your college? Is happiness predicted by quality of sleep a day before? So can I predict, can I know about your level of happiness based on your scores on the sleep a night before? So all these things can be possible by the concept which we are just going to discuss, that is regression. But to know, to understand regression and to calculate it, we need to know first of all that the two variables must be correlated. So correlation is a necessary precondition to making predictions. If the two variables are not correlated, then regression does not make any sense. Now what is regression or a regression analysis? Regression is a statistical technique based on the numerical relationship between two or more variables to estimate or predict the change in a dependent variable based upon the changes in one or more independent variables. So we use the term dependent and independent variable, and we also use the other terms which will just which are criterion predictor. But before that, we need to know three things about regression. That first, it is a mathematical model. Second, it depicts relationships among variables. And third, it can be used for the purpose of prediction of the values of the dependent variable given the values of the independent variable. So in a way, it can be used to predict or forecast the present or the future events based on again the present or the past events. So it is not necessarily about forecasting something in future. You can predict anything in the present also based on one variable. So here we need to know that which variable is being predicted from which variable. So the variable which you are making predictions on is called the criterion variable or y, and the variable which is you are using to predict the other variable is called the predictor variable or the x. So in a way, the predictor variable is the independent variable and the criterion variable is the dependent variable. Okay, so when we use IB and DB, we say the dependent variable is dependent because on the values of the independent variable. So similarly here, predictor variable is guiding, is so you are estimating the values of the criterion variable based on the scores on the predictor variable. Take examples like which we have just discussed, sleep and happiness. So if I am estimating your happiness levels on the basis of your sleep quality a day before, then sleep becomes my predictor variable and happiness becomes my criterion variable. If I am predicting your college grade point average on the basis of your SAT scores, then your SAT becomes your predictor variable and the college GPA becomes the criterion variable. So this is about prediction, and this prediction can be done in two ways. One is done on the basis of Z scores or Z scores, and the other, which is the more popular, is the raw scores. We will see both. Let's start with the Z score or the Z score formula for making predictions. Now, the formula is very simple. It says Z cap for the variable y is equal to R into Zx. Now, Z cap is basically, cap is to denote something which is estimate. So, you are estimating the value of y, the scores of y based on the scores on the Z. Now, here Z scores are the standard scores, they are not the raw scores. R is the Pearson correlation coefficient. So, Z scores, for example, which we have taken, Z scores for the college GPA variable is being estimated from the Z score of the SAT variable. Now, to take an example, suppose your correlation is plus 0.5, your Z scores for your variable X is plus 1 standard deviation. So, if you put into that formula, you will get your Z for Y as to plus 0.5. What does it mean? It means that person with a SAT score of plus 1 standard deviation would have plus 0.5 Z score on a college GPA. So, this is the Z score formula, but in real life or in most of the statistical analysis, we do not use Z scores, we use the original or the raw scores, because it is difficult to calculate the Z scores. Normally, we get the data in the form of raw scores. So, we also need to learn the calculation on the basis of the raw scores. This we do by linear prediction rule. What is a linear prediction rule? It is a formula for making prediction, for predicting a person's score on a criterion variable based on the person's score on one or more predictive variable. Now, score here means the raw scores. We will see how. So, to predict a person's score on y, which is your dependent variable, start with some baseline number which we can call A. A is a constant here. Then add it to the result of multiplying a special predictor value which we call as B. We multiply it by what? By the person's score or X. So, the formula becomes y cap is equal to A plus B into X. Now, what is y cap? Again, because y is an estimate, it is not the actual value, it is a predicted value. We are predicting it. So, it is a cap there. So, y cap is a predicted value of y. A is a coefficient A is a constant which we call regression constant or just a constant. B here is called the regression coefficient, and X is your score on the predictor variable. Now, how do you calculate this A and B? Although generally we are normally given these A and B values. So, I am not going into the details of how to calculate, but statistically there is a formula for everything. So, it is given that B can be calculated by sigma y upon sigma x into R, where sigma is the population standard deviation of y and x, and A can be calculated by mu y minus B into mu x. So, once you calculate the B, you can calculate the A by the following formula, where mu is a population mean, okay, for both y and x. Similarly, there are some linear equations which are given, and A and B can be found by solving these linear equations also. Once you get your A and B, you already have your x, you can easily calculate the y cap values. So, once you do it, you will get the y cap. And what does it mean? What does the formula indicates? It indicates that each unit change in x produces a change of B in y. So, this value you will get positive if the relationship is positive, correlation is positive and direct, and if the same value will be negative if the correlation between two variables is negative or inverse. Now, we will take an example, a hypothetical example, to solve and get the y cap value. So, we will again take the example of a SAT and the college GPA marks. So, if we want to use a SAT scores to predict the college grade point average, where the regression constant is 0.3, the regression coefficient is 0.004, and SAT score we have taken randomly as 650. So, when we apply this formula, you can see here, this can be highlighted. So y cap is equal to a plus b into x. So 0.3 plus b value is 0.004. You can see, you just apply it into 650. The following values you get 0.3 plus 2.6. So in total what you get is 2.9. So your predicted GPA is 2.9. Now we will talk about the regression line. A regression line shows the relation between values of the predictive variable and the predicted values of the criterion variable. So it is a visual display of the the two variables which you are showing and the relationship between that. So for that regression line, again we have to have all the values and we have to have the y cap, the predicted value. So for example, you have your SAT scores. The SAT scores are given, for example, from 0 to 100, 200, 300, 400 and all the SAT scores. Now you want to have the predicted GPA. So if I have my A and B values with me, I can get the predicted GPA values. Now how do I do that? I apply the same formula, and for each x value I calculate the each predicted y cap value. So for 0, if I put in this formula, okay, I put x as 0, so this b into x becomes 0, and a we already know it's 0.3, so y cap becomes 0.3. Similarly, I do it for all. Suppose take the value of 200, so I put the value of x as 200, my b is already 0.004, so if you multiply it, you will get a value, and when you add it to 0.3, the value which you get is 0.7. Likewise, you can calculate it for all the x values. Once you have your x, your y cap, then you can get this regression line. Now in this you can see, you can plot this regression line. So when we know that at 0, at the value when my x is 0, my y value I got is 0.3. So I have to plot it here. You can see, okay. Now similarly, just go back and you will see when my x is 100, my predicted y value is 0.7. So I take the 100 value on the x axis, I plot the 0.7, I see where there is a 0.7 and plot it, and then there is a put a dot here or a mark. Similarly for 200, for 300, when I plot all the values, I just connect it through a line, and this line is my regression line. Now here this line is a straight line. Let us understand what the slope means here and the other things first. The steepness or the angle of regression line is called the slope, which is exactly b, the regression coefficient. So when you calculate it, it comes out to be b, it is 0.004 here. So what does it mean? It means that whenever two students differ by 1 mark in SAT score, they will differ by 0.004 grade points in the college GPA. Now 1 marks in a SAT score, it is very difficult to calculate. So what we do it, we make it 100 marks. We just multiply it by 100. Similarly, we do the same. So we multiply there also, on the other side 100, 0.004. So we get the value of 0.4. So in a way we can say 100 marks difference in SAT scores will lead to a 0.4 points change in the GPA. So we are predicting in a way the difference in the GPA based on the difference in the SAT scores. So this you will get through the slope. The other is the intercept, the point at which the regression line crosses the vertical axis. It is called the intercept or the y-intercept. It is the value of y when x is 0. So just look at the graph again. It is a value of y when x is 0. So here we see the value is 0.3. Okay, so when x is 0, the value is 0.3. This 0.3 is the y-intercept. Okay, I hope you can see that. Now this is exactly the same as a regression constant a. So when you calculate the y-intercept, it comes exactly equal to the regression constant, and similarly when you have the slope, it is exactly equal to the regression coefficient. In our example, when the person has SAT score of 0, they are predicted to have a college GPA of 0.3. This is a regression constant which you get. So, in the diagram, in the graph which we see, it is a very straight line and there are no points here and there. Okay. Now, in reality, it does not happen. You do not get such a clear straight line and all the points which can be joined through the line. So many times, because this is an example of a perfect correlation, and in real life we so many times don't get a perfect correlation. We can get a correlation of 0.7, 0.8, 0.9, anything. So in that case, how do your regression line looks? So in that case, when you do not have a perfect correlation, then it also indicates that there can be some error in the prediction. So how would it look like? It would look like this. It is a So the points are, there is a line of best fit, which you can see the straight line here, this blue line, and there are scores which are scattered among it. So we are not making a 100% prediction. We are not 100% sure about, on the basis of X we cannot make the Y. It is not a perfect prediction. Okay, but yes, it can be very close prediction also. So in this case, these are the points which are away from this regression line. Now these points are showing some kind of error in our prediction. Okay. So the line of best fit is a line which is crossing through most of the points. So on this line will lie all our predicted values of Y, denoted by Y cap, made from our understanding of the X values. This is a line that best fit when drawn through the various points. It also minimizes the distance of the actual scores from the predicted scores. So the more closer are the actual scores to the predicted scores, the better the prediction, the more accurate the prediction, and the more spread is there between the actual scores and the predicted score, then there is a higher chances of error, or the term which we use here is a residual creeping in. It brings us to the concept of residuals. Now what is a residual? Residual is a kind of you can see this is a line of best fit which is predicting the scores, but there are so many scores around it. So our line is not able to connect those. So this shows the difference between the actual scores and the predicted score. So this is a residual. This is a kind of error. Okay, can you see there are residuals being plotted and the distance is also shown. So this is a distance from the actual score to the regression line which we are predicting. Okay. Now residual is a prediction error while making the prediction, which is calculated by Y minus Y cap, where Y is the actual value and Y cap is a predicted value. The closer a data point's residual is to 0, the better the fit. Yes, this seems to be very logical, because if your error is 0, then it is a best prediction which you can make. To check the overall error in prediction, we sum up all the squared deviations from the regression line by squaring, because if you add the deviations, the total comes out to be 0. So we don't add the deviations, we add the square of the deviations. So what do? We calculate the Y minus Y cap square and then we add it for all the points. Okay, and when we divide it by the total number, it gives us the error, the amount of error which is there in our prediction. It is also called residual variance, or it is also called variance of the estimate, which is denoted by sigma square estimate Y. So this is about the residual and the error and the line of best fit. So a line that has the smallest square deviation is a line of best fit. Yes, we have discussed it. When correlation is perfect, residual variance is 0 and there is no error involved in the predictions. Yes. So when your correlation is perfect, your prediction will also be perfect, it means to say. Now how well is your regression line doing in terms of predicting one variable from the other? You can know it from the another concept which is called the coefficient of determination. We will not be going into the details of the calculation, but yes, this is a concept which you should know. It is a ratio of the variance explained by regression by the total variance. So sigma square of regression and sigma square y divided by sigma square y is equal to your coefficient of determination, which is also denoted by R square. R here is a coefficient of correlation. So you can find the coefficient of determination either if you have the coefficient of correlation with you, then you can find the coefficient of determination by just squaring it, or you can find it if you have the variance of the regression which you have got from the regression and the total variance, and if you divide it, then also you can find it. Now for total variance, we have to know what is the level of, what is the variance which is caused by the regression and which is the variance which is caused by the error or the residual variance. You need to, so that is the total. When you add it, you get the total variance. The easiest thing is, if you have the correlation, statistically it has been shown that the coefficient of determination is the square of the coefficient of correlation. So you just square it and you get the, so for example I have given here R, if it is 0.5, your R square will be 0.25. And what did it mean? It means that 25% of the variation in GPA is being because of the variation in the SAT scores. So only 25% of the variation is there because of SAT scores. The rest 75% might not be, maybe from other factors. Okay, so this is not a very good prediction actually. Now what are the factors that affect the linear prediction rule? We should know the most important factor, there can be others also, but the most important factor is the scale which we are using in terms of for our variables. So the scale which we use might be a 5-point scale, it might be a 7-point scale, it might be a 20-point scale, depends on the the demands of the research. So the scale which we are using for the criterion and the predictor variable will affect the value of the regression coefficient and the regression constant also. So if you change the scale, the values of A and B changes. So for example, you as a researcher, somebody is studying the relationship between the sleep hours and the happiness. Is there a link between the number of hours you sleep, the quality of sleep and the happiness? So they can take a scale of 0 to 5 in terms of happiness, measuring the happiness, where 0 is not at all happy to 5 as extremely happy. But some other researcher is taking 0 to 8 scale and is using the mid values in a different way. So now your A and B value for that researcher might change. Now in that sense, when we have the similar thing, you might feel it is very similar to the using of raw scores. Okay, so we say that in raw scores this problem arises that if we change the scale, then the values of the other things which we are finding, they change. So what do? We convert the raw score into a standard score, because raw scores are not comparable. So we convert the raw score into a standard score or a z-score. So the one purpose of z-score is that it is not affected by the scales value. So they can be used even when the two variables use different scales, so that we do. Likewise, in this regression also, we can use the concept of standardized regression coefficient. Now what is it is similar to the whole concept of z-scores. A standardized regression coefficient denoted by the symbol beta, it shows the predicted amount of change in standard deviation units of the criterion variable if the value of predicted variable increases by 1 standard deviation. Just take an example to understand it better. So if you have a standardized regression coefficient of 0.63, what it would mean? It would mean for every increase of 1 standard deviation on x, we predict an increase of 0.63 standard deviation on y. We are not here learning about how to calculate it, but just the concept of a standardized regression coefficient and what does it mean. Now in case of one criterion variable predicted from one predictor variable, the values of the correlation coefficient, the Pearson correlation and the standardized regression coefficient, they are the same. So it is not necessary to use a standardized regression coefficient when you have only one criterion, one predictor variable. But it is not the same as the correlation coefficient when scores on a criterion variable are predicted from more than one predictor variable. So the values of the standardized regression coefficient differ from the correlation coefficient when we have more than one or two predictor or in the independent variables. So this brings us to the last topic here, which is a multiple regression. Now, what is a multiple regression? Like it's like a multiple correlation which we had studied earlier. So, making predictions between a criterion variable and two or more predictor variable is called multiple regression. So, when you have more than two independent variables and one dependent variable, so we can use the technique of multiple regression. Take an example of sleep and happy mood. Instead of taking only number of hours, now I am taking 2 or 3 things like number of hours of sleep, quality of sleeps, and even the dreams I have taken, or you can take any other thing here on happy mood. So, in this the formula for y cap would change a little bit. So, the constant will remain the same, the regression constant, but the value of regression coefficient would change with each of the independent variables. So, the formula become y cap is equal to A plus B1 into x1, you can see here B2 plus B2 into x2 plus B3 into x3, where B1, B2, B3 are the regression coefficient for the first, second and third predictor variable, and x1, x2, x3 are the person scores on the first, second and third predictor variable. So, what are the limitations of prediction? Limitation of prediction is same as the limitation of correlation. So, it will not be accurate when your correlation is curvilinear, when the scores are restricted in range, when the measures are unreliable, and when they are outliers. So, all these characteristics, all the criteria which we use for correlation coefficient, we also use it for the predictions. So, when these conditions are there, then regression coefficient will not be accurate, either will be overestimated or underestimated. Also, prediction does not tell us anything about the causality or the direction of causality. So, it is not again cause and effect relationship, which we will only get through experimental research. So, this is all about regression and prediction. Here we have covered the regression, the meaning of regression, the linear prediction rule, the line of best fit, and the limitations of regression. I hope you have understood this topic and enjoyed this lecture. Thank you so much.